Dooby dooby doo be doo. Dooby dooby doo be doo. Dooby dooby doo be dooby doo. Dooby doo. Hey, hey, we've got intro music. Wow, do you like it? I do it myself. Hi, welcome. I don't seem to be in the right place here. Just 1 second. Yeah, right. There's the microphone. Okay, all right. I think we're setting up okay. Okay. What's today's stream about? Hey. What are we all about today? Oh, right. The game dev studio. We're actually going to start. Well, yeah, it is the beginning of the month, isn't it? Yeah, we're starting it. We've got it all set up. It's an empty. Well, it's an empty space which we can fill. We did mess around with Delta time, a clock, and well, I thought we'd finished it until the next day I looked at the code and thought, no, we haven't finished this at all, have we? Let's be honest. Yeah. Let's just run the code first of all. This is the test, the main function for our clock. We're putting up a welcome message. We create a new clock. We'll go to the code in a minute because it's going to get changed. We set up some variables for measurement. We restart the clock so that it only measures what we're doing, the test code, which is basically a for loop. We are enforcing a frame rate, so we set it at 60 frames per second, which is what, 16.66 recurring milliseconds. We measure how long something took, and we do this how many times? 60. So we do this over a full second or so. We do this 60 times. We're just matching it up. So we're asking for 60 frames per second, so we're going to measure a second's worth, and then we just print out the accumulated time and the last delta time. All right. So when we run it, something surprising happens. And I do know about this. We took 1.022 seconds. We're 22 milliseconds over. Now, if we've got a delta time of 16 milliseconds and we're taking 22 milliseconds too long, we're dropping 1 to 2 frames per second. Just with the code that we're using. And I don't think programmers realise how difficult time is to measure on a computer, and I've been through all of that, so I'm not going through it again. We're dropping 1 to 2 frames per second from the clock code. Can we do better? Is the real question. What's taking that time? Well, we're measuring this part of the code, so that's not the problem. The enforce could be part of the problem. And then we just measure how long. So it's there. There's our problem. This will cause a little bit of a discrepancy. We've got a restart here, haven't we? So there's our problem. We've got a restart and an enforce. The accumulated time bit shouldn't be too much of a problem. We can't do any. We can't shorten that. So there's nothing we can do about that line. But what can we do about this restart and this enforce? Well, what I'm thinking is that we're using floating point. Now, when I started programming 40 years ago, using floating point calculations was a big no-no. The processing units, CPUs that we had at the time, didn't really do floating point that well. And it's also an area of contention for error in calculations. Let's just check that. Yeah, that's looking okay. So floating point could be part of the problem, but modern day CPUs have floating point calculation modules in a mass coprocessor. So I don't think that the speed of the calculations is a problem. Maybe it is. So how could we change that? And this line here, so this is our code. We've got a clock object, and I'm thinking change from seconds to nano. So we're measuring in seconds, which is an F32, a floating point. We could, and I put U128, 128 bits. Oh God. Mind you, there are 1,000 million nanoseconds in a second, so yeah, I can see why it would be... why not just a U64? Why would we be using two unsigned integers to represent a nanosecond? Well, I was playing around with code, as I do a lot. You may now know I play around with code. Yeah, I enjoy playing around with code. Look at that line. That line comes back as a U128. And that's coming from the Rust standard library. That's interesting. So let's change everything over to U28. Let's do all our calculations in U28. So if we do that, this is going to cause a lot of errors. Here we go. Done. Alright, so we're swapping over to this U128. So let's do that. So our frame rate is now going to be in nanoseconds. Interesting. We have to change this over. Okay. So we now have nanoseconds. Well, we're returning an F32 here. So we can't do that, because that's now in nanoseconds. I can prove that. It's going to go red. Doink. There we go. We're all going red. So elapsed time is now our next problem. We can't do that. What we would have to do is that. So we have to take our F32 And we have to, well, we have to take our elapsed time, which is as a U128, an unsigned integer, and we have to convert it to a floating point and then divide it by the nanoseconds per second as an F32. Nanoseconds per second is here. There you go. So there's your nanoseconds per second. 1,000 million, or a billion. Some people might call that a billion. It depends whether you're English or American. Alright, so we're okay so far. We've changed a little bit of code around, but you can see it's now become more complicated. We've got some conversions going on. So, let's get rid of... No, we can't get rid of that line yet. Alright, we've got another to do here. Avoid division by 0. Remember, somebody might ask for a frame rate of 0. In other words, they don't want a frame rate limiter. So, I would like to do that for testing. I'd like to be able to change it and just say, hold on a minute, I don't want a frame rate limiter. Let me just stick a 0 in and switch it off. So I can see exactly how long things are taking without this limiter going off. So to avoid the division by 0, we can't do this. So that's rubbish. What we have to do is an if statement. Yeah, this code's getting worse, not better. You know how I hate if statements. So if the frame rate is equal to 0, then we set it to 0. If it's not equal to 0, what's wrong with this? The frame rate is going to be nanosecs per secs divided by the frame rate, or 1 divided by the frame rate as a 32. The frame rate here, we found a U32, so we need a U128. There you go, you've got a U128, mate. There we are. So we now have this horrible if statement to avoid the division by 0. Alright, we'll say that's done. Okay. So we've got 2 to-dos left. Let's see how many errors we've still got. Coming down, so we set our frame rate limit. The code has gone a bit ugly. And we're down to the enforcement of the frame rate. So the elapsed time self.frame rate, what's wrong with you? Expected F32 found a U128. Okay. So we want nanoseconds, don't we? So this is now wrong. That puts it to a U128 for us. Okay. We just kick the ball down the road a little bit. Self frame rate minus elapsed time. So what's wrong with this? Expected an F32, found it a U128. We did. From secs. So here we have to go to nano as well. There we go. Expected a U64. There's a little bit of inconsistency going on here, isn't there, in the standard library? So we actually have to convert this calculation Let's see if we can do that. No, I don't want it there. So we'll put it here. Has U64, please. There you go. That's a bit ugly. So that's a U128, that's a U128, that turns it into a U64, which gives us the U64. This gives us a sleep time duration, which it can now handle. Lovely. Bit ugly. But we've also got this to-do statement here. Remove the if statement. Well, we've added one up top, so we may as well remove this one whilst we're here. How do you remove an if statement? Well, if you sleep for a duration of 0, then there is no sleep. If statements are Boolean. So this here is a Boolean value. It's either a 0, false, or 1, true. If it's a 1 and it's true, we want to sleep. If it's false and it's 0, we don't want to sleep. A sleep of 0 is not a sleep. So we can take this Boolean statement here and we can put it here. So we've got the brackets in already. That's lovely. And I'm going to put it there. Yeah, because our duration is here. As using, no, it doesn't. It goes in here. So we can multiply that by this. And we usually bracket up Booleans. That looks awful, doesn't it? Yes, it does look awful. Is it right? Which means we don't need this line here. Which means we also don't need that line there. There we go. So we're just doing a sleep statement now without an if statement. Is that more efficient? It's still an if statement, it's just a Boolean if statement. Which is actually more accurate. Okay. So everything now, that to-do's done. Everything is now looking a bit better. We've still got that to do. Have we changed to nanoseconds? Yes, we have. We've got as nanos everywhere. Everything's coming in as unsigned integers, which should be faster to calculate on any CPU. Modern CPUs, not necessarily true, but, you know, that's the state of modern computing. Have we really gained anything? Well, there's a problem with this, that now even that we get a 0 here, we're still calling a function. Whereas before with the if statement, we weren't calling a function. We'll see. We'll see on that one. All right, we have converted to nanoseconds, so that to-do's out. You're done. We should have no to-dos left. Correct, which means we should be able to run the program now. We're looking for something better than a 22 millisecond gap. Oh, we get cannot multiply U64 by bool. Oh. Okay. So, we've still got an error. That bit there is as U64. I don't think we can do this. You're going to let me? Really? Yes, it did. Oh, look, it took exactly the same amount of time. How did I guess? Yeah, it seems modern computers aren't as stupid as we thought they were. So can we stop this from happening? Not really. Do I prefer the U64 to the F32? Not really. But it doesn't matter, I've still got a conversion there. Don't think this really matters. Can't believe they put a U64 in here when they put U128s up here. That seems a bit weird and daft. I think I'm going to take it. What happens if I format the document? Oh, it does that anyway. Okay. Fair enough. So let's clean up the code. I'm going to accept this version. I wanted to test it before I accepted it. So clean up the code and let's go through now. Blah blah blah. Create the clock, start the clock, construct and return the clock object. Yes, everything's okay here. I don't like the I think a U64 is fine. We were printing that out, weren't we? Oh, we are converting. That's fine. Frame rate, F32, F30. We didn't need to convert any of this. My biggest problem was having to convert any of the test code. I didn't want to do that, so we haven't. That's good. That's very, very good. So what don't we need here? We don't need this line. So we can pop you in there. We don't need this line. So I can pop you in there. Yeah, we are converting back over. That's good. I'm happy with that bit. Okay, this now looks ugly. Can we do anything about this? This if statement? It's not Boolean, is it? We've got a 0. We can't multiply this by 0 if the frame rate is 0 because of a division by 0 error. That's stopping any kind of Boolean operation. Okay. Fair enough. So we can enforce this. Alright, we don't need that line. So we'll take that out. We don't need that line, so we'll take that out. It cleans up nicely. Set the frame rate limit doesn't matter, does it? Because it's here. It's not within... Yeah, so that's okay. That if statement's better there than it is here. Alright, I am happy with that. I wonder how much Rust is doing in the background with the compiler. I think we've got a final set of code. Yep, this is looking like a final code piece. The functions are the correct sizes now, and we don't have this statement. Well, we do, it's here. So if you didn't know you could do that, look up Boolean logic and Boolean calculations. Very, very important in game programming to be able to get rid of if statements. Because if statements kill games. You'll hear AAA games saying, oh, it hasn't been fully optimized yet. That's one of the things that they optimize. It's called code paths. Instead of a code path going through your CPU, hitting an if statement and branching off, it just goes straight through your CPU because there's only one code path. In the bigger scheme of things, that helps a lot. I'm going to try this out actually, because I'm happy with that code. I'm a lot happier with this, but not that. That's too big. But, well, the options aren't there really, are they? Because of this thing. Because of this one line. Dictates what we have to do. We could minimize it down to a U64, which would speed it up. We don't need a 128. But how many times we've got as nanos in the program? 2. One of them is in enforce. If we do go down, we get rid of that as. We can shrink it down. Let's do our test first. Now, here's an interesting thing. Rust, when it compiles in debug mode, doesn't really do much to your code. So let's set a time. 24 milliseconds dropped. Okay. So what I want to do is release. Not doing much, is it? Yeah, dropping 25 milliseconds. It's probably because I'm streaming. That'll go down to about, what, 18 milliseconds are non-streaming. So changing it over really doesn't help. As I suspected. Once upon a time it would have done. We're also adding this nanoseconds per second. So restart has this calculation in. I don't think it's worth that. What kind of timing are we getting out on this? 25 milliseconds out. That's a lot. That's nearly, yeah, it's 1 to 2 frames still, isn't it? Okay. We've also got this horrible variable hanging around our system. Which I don't think we really need. So I'm going to disagree with it. Disagree with the need for it. And we're going to go back to seconds. Alright. Okay. Floating math compounds the inherent inaccuracies. Well, it's not really doing that much. It does compound the inherent inaccuracies. No, we don't need you lot anymore. We've looked into you. We've decided you're not doing much useful. So we'll get rid of you. And we'll get a load of errors now. So let's just get rid of our errors. Ba 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 ba. So we don't need this because we can go back to seconds. Start time. We can get rid of all of you. So that cleans that up. It's cleaner to go with seconds, F32s, which is amazing. This can go back to a U32. If frame rate equals 0, set frame rate to 0.0. That's easy. Otherwise, it equals 1.0 divided by frame rate. Frame rate is a U32. There we go. So I've only got this one as here. That's a bit better. These conversions take time. That could be one of the problems that we're encountering here. So elapsed time is now going back to as seconds. That one. Okay. So frame, that's in F32, that's in F32. We no longer need you. Elapsed time is F32, frame rate is F32. We don't need you. And we've got a multiplication now that's saying, hey, buy a bool. All right. As F32, which we can't do. This is where Boolean logic expected a U64, found an F32. Okay. Oops. Yeah, we do need it in here, don't we? Okay. Because of this duration thingy. Well, can't we turn this over to from sex? Yeah, we can. Which means that's an F32, that's an F32. Yeah, we can get rid of that bit. Which just means we need this as an F32 now. I don't think we can do this. No, you can't. Casting bool as F32 is invalid. Needs casting through an integer first. Did you know that? Yeah. Ba 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 ba. That's awkward. We've got a double cast now. This is ridiculous. Don't like it. This is one of the problems with Boolean logic that I found on Rust. You have to go with the I32. Should we pre-convert that? This is an awful calculation now. It's an if statement workaround. What does that... so this is the Boolean logic. What we can do is... if the logic says this, which gives us our F32, we can then put it in here. Yeah. So this would be Boolean logic to avoid an if statement. Does that make more sense? I think that's more clear. Yeah, I think that is more clear. That'll help me know why I've done it. Putting things in like this means a lot to me in the future, so that's why I probably do it that way. Also shortens the code a nice little bit there. I think I'm alright with that. Yeah, this code is short enough now. And it's working on an F32. Alright. Just run normal, please. Yeah, that looks okay. Coming up with 22 milliseconds in debug mode. In release mode, we're coming up with the same. It's not doing much there. Yeah, that's better code. I'll go with that. I'll go with that. So this is my code. This is the code that I want to use in our game studio. Now, how are we going to use this code? Well, we're going to use it in exactly the same way that we've used it here, is the answer. Oh, we haven't checked. Frame rate of 0. Yeah, that looks about right. 6 milliseconds though. 378 milliseconds to run the test. Okay. All right. I understand. I understand. That's fine. That is fine. So at least I can now put a 0 in here and not crash the computer. That's good news. Let's go with all of that then, shall we? Alright, so under here we have our Rust project, we have our game studio. Right. We have source data, we've got application info, an application. How are we going to structure this? I mean, we haven't given much thought to it. So now it's time to start thinking about how can we structure our game studio to accept new files just being dropped in from outside. There's a good question. Remember, this game studio is going to evolve. How do other projects handle this? Okay, I think that's a fair enough question. Let's have a look at... Well, we've been using SFML as a guide, so let's see how they did it. Let's have a look at their repository. So their source code, Windows System Graphics FFI CPP Audio Window. Okay, so if we have a look in System, we have a mod RS. That's interesting. I didn't know you could do that. Define various utilities. It provides vector types, time types. Yeah. I don't know what this is about. I've never come across this before. Public use self. Oh, I see. Oh, that's clever. Huh. Maybe we should go down that route. It seems to be like standard practice within crates and things to do that kind of thing for libraries. Alright. Well, we'll finish with this. Let's have a look at our game studio. Alright, our game studio looks a bit like that. It's got a source. It's got a studio library, which is what we'll be looking at. Okay. So we should be in here. And we've just got lib. Which I'm not sure whether we need that or not. Yeah, they've kept it in. Extern crate mods, pub mods. Right, I got you. We got the errors in here. results, okay. And a load of warnings, stuff for Clippy and unsafe code. And something to do with documentation. Okay. So they've actually got the configurations for the feature equals. Ah. That's interesting. I didn't know you did it from here. Always wondered how that worked. Okay. So I'm thinking we're probably going to have a system folder. That might be good. Okay. Let's just call it system folder. We'll pop you in. In the system folder, I'm going to put a mod RS. Is it just mod? Yeah, it is. .rs, so we'll do that. Which means we can now drop things into our system folder and tie it into the library using mod RS. Okay. So this is time, source, and it's just time. Just do a copy. Can I just drop it in? No, let's not do that. That could cause problems. So we'll just copy that into our game studio, I think. Into the system folder here. There we go. Done. What do we want to call it? May as well call it time. Don't see why not. Alright. I do see why not. They're splitting it here. Yeah. Alright, I'm going to leave it as time. Alright, so in our mod RS here, what we do is we just put mod time. That tells it that that exists. Like that. I'm not overly sure about this self thing. But maybe we should put it in. You see, we're not making this available to the library. We're making this available to anybody using the library. The system that uses the library sometimes uses self. I've got a feeling that helps the Rust system, the cargo system, pick things up. Okay. So it's probably a wise idea when building a library to do this kind of thing. And as this is the first item we're introducing, maybe we should set a precedent for future inclusions. This is the first library I've ever built in Rust, so how... I mean, we could just use that, but we then have to put public mod, don't we? I see. I wonder if that's how it works. Whatever decisions we make at this point in time affects how we work going forwards. So we'll do things properly using the example that we've got, and that would be time, colon colon. We don't get anything. Clock. It does come up. Comma. We need a semicolon at the end. Of course we do. This file is not included anywhere in the module tree. Oh. Right, I've got you. Is that just time then? No, it isn't. I'm not sure I can use this. Yeah. Okay. Oh, we have to alter this. So what we have here is something or other. How are they putting it in? They're just saying mod system, public mod system. Okay. That says it's correct. The name time is defined multiple times. Oh, right, okay. Now it starts coming through. That's correct. Now what's wrong? Unnecessary braces in the use statement. Okay. We'll do that. So that works. Okay, that works. And it's not complaining about anything in here. Wow. So that sounds as though that's the kind of setup that we want. What do we think? Should we do it this way? It's one of the reasons I wanted to see how we added things to our library. I like this idea. It's clean. Okay. Right, can we use this? I think we should be okay. Okay. So we've got our studio lib going. Back in our application, are we allowed to just use it? Use Studio Library System Clock. Okay. It says yes, we're allowed to use it. Wow. That seems awfully straightforward, doesn't it? And it's coming up with the correct prompts on like the IntelliSense stuff that is generated by the Rust Analyzer. We know that delta time is an F32, so we can put that in. We also know that we don't have to go as complicated here. We can just put a 0.0 in. Alright. Down here we've got a clock. So we should be able to... No, don't do that. Self dot delta time equals clock dot restart. It's coming up. It's got an F32 on it. We don't need our seconds because we've programmed it to take seconds. Cannot mutate. All right. That's looking good. But we also have something slightly different, don't we? Which is hidden. And I'm guessing it's hidden there. But even so, we have to put an extra line in here where we have to enforce. So when we start the clock, we also have to put in clock set frame limit. Yeah, we'll type in 60. There we go, we've got a frame rate. So we've got some extras. Here we can do clock frame rate enforce. To stop it spinning around the main loop at 200 million miles an hour. Is this correct? Have we got anything else in clock that we haven't used? The easiest way to check it is just put clock dot. Frame rate enforce, restart, and set frame rate limit. I don't think we really need the frame rate to be public, as we can set the frame rate limit ourselves. I think that variable should be hidden at this stage. Okay. So there is one alteration that I'm going to do. Can be altered later. We do have a public frame rate. Does that break our code if I take it away? No, it doesn't. It's because in our testing we were accessing it for the test. Whereas in a real application we wouldn't. Alright, I think I'm okay with that. Okay, let's go with that. Works. Well, I think it works. I mean, we're not printing anything out. We could put some debug code in. Yeah. I'm just thinking if there is a way to put some debug code in here that is useful. Not really. We could just print out the final delta time. That wouldn't really help, would it? Maybe it would. We're returning an elapsed time. Yeah, that's okay. I'm trying to think if there is a good way of doing this. It would have to be within here. This code looks wrong. Yeah. Correcting the code. Notes. That has to come within the application is running to do a shutdown. Can't do it between run and implementation. Alright. I'm going to put a debug code in. So debug remove this code. We're just going to do a print line. Debug. So I'm just going to put a delta, final delta time. Yeah. We'll just pop in here a self dot delta time. That should be fine. Debug final delta time equals that. Yeah, that is correct. But it isn't. Ah, yes, because it doesn't include that. Yeah. We haven't looped. So that's how long it's taking to run our program. So that tells me that we're not looping through our run loop, which is correct. That's awesome. Well, obviously we're not, because that isn't in at this point in time. Okay, I'm happy with the results. So I can get rid of some of this now. Right, let's tidy this up. So what have we done? We've now got this line. We put it into 2 lines, but that doesn't matter. That's fine. Alright, so we're going to have that. We're getting code. Restart as seconds. We only need to do a restart because we programmed it as seconds. So I've got that line now. Alright, let's take that. And we've got this extra frame rate, which we're just going to leave knocking around for a second. Not sure how I want to note this. Make sure we don't exceed the frame rate limit. Yeah, that'll do. I also have to put in an extra line here. Just to put an end marker in case I need it. Alright. And we can just clean up some of this garbage that I've left lying around. We don't need any more timing in here, although we do have this stop weird time behavior thingy going on. We can add that in now. All right. That goes to there. Right, we have to move that. Our frame rate enforcer, where do we want it? I think it's part of the renderer. Maybe we do want it here then. That's an interesting thought. We are missing. That should be the last thing that we do. Okay, just matching up some of the brackets. Yeah, that matches up. That ends the running. Okay, I'm slightly happier now. That code doesn't belong to that code. Everything's looking okay. That's cleaned up. Alright, let's just move back up here. Alright, documents are formatting properly now. Yep. Yep, don't need to mess about with anything here, do we? Not really. Yeah, we're going to have to do that. Oh my god, I'm actually happy with that. There you go. That's how you add something that you've developed. So if we come across any problems with this, we can now go back to our development area and alter anything that we want about delta time and then copy that file back over. I think I prefer that. I like system then clock. I like the way it's done that. That's very nice. Yes. It's made it very clean. So looking at how they've coded things before, you know, people before us, how they've coded their libraries is definitely a bonus, having an example to go off. I like that. All right, we're done. We've done it. We have completed our first clock, or our clock code. We've implemented it, we've tested it, we've messed around with it. We've now got it in a format that I think is usable. Yeah, we've got a couple of extra lines here and here, but these lines of code, remember, are in the original, just not evident in the original. That was hidden within inside the window class, and this, I believe, is hidden within the rendering class. But I don't know if I don't think it's called enforce. That's just something I made up. Okay. Huh. Yeah, it's just going to give us that. What's it going to be? Target debug. Well, that's interesting. Our game studio is at 175k, which is probably where I would expect it to be. So what I'm not seeing here, I'm not seeing a library. Huh. There's nothing in build. Ah, here we go. Is there any studio? Ah, there it is. Yes, it is coming through here. Coming under the dependencies, and it's being built into our executable. So that is a static build. Wow. Is that good? It is something I might look at later on to see if we should have that as an external dynamic linking library rather than a static linking library. But a static linking library is better for us. Yeah, I'll go with that. I'll go with that for now. So what we've got at the moment is a static linking library. So I better note this in here. Yeah. Currently this is a static link library. As long as I know it makes a difference in the long run. So I think we should need, well, yeah, we should do that. Yeah, that's fine. Alright. I'm good with that. So we've now added a delta time clock. Wow. I didn't put a search on to-dos. To do. We've got a debug, read data in, yeah, and enum. Right, okay, that's in info. These don't matter. Debug does. Replace is running. Yeah, I know about that one. Okay. So that's our base setup. So this is going to be clock for delta time. Yeah, I think that should do. And we'll just commit that. There we go, clock for delta time. All completed. I think we should really share this. I think we should share this code now because it's got quite a bit of setup in it, which... What do we think? Yeah. If I publish this, that'll give everybody access to it. But we don't have enough yet to run a program. Okay. We need enough to run a program, really, don't we? Alright. Fair enough. I can't remember which letter it is now. It's not R. Oh, we're in there, are we? There we go. And it shows how you can cleanly put together a library which doesn't mess up everything. Wow, I like that. So as you can see, we're extending the library, not the application. So all our code, or most of our code's going to go in here. This gives me quite a bit of free time to mess around with, doesn't it? Hey, 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 hey. So we can look at this now. What other ideas do we want to come up with? Well, a window. We're probably not going to do ECS. We're going to replace this with tables. so we won't need the register components. Might need a load tables. We could do that from file.io. Create our game entities and store in ECS. So all of this will go. This is running true thingy. I can't put that in until we can get operating system events. We can't get this while loop going until we've got input events of some kind to be able to close a window. Otherwise, we're just going to be stuck in a while loop. We now have delta time to enforce the frame rate so our while loop doesn't go stupid and burn the house down. I think we've already proved that works. I think I'm happy with that. To get operating system events, we're going to need something called Windows 32 API, aren't we? Yeah, we are. Do we need to finish the tables off? We've got a table for experimentation. That code works. We might be able to focus down on Windows now. The creation of Windows. What does that involve? The Win32 API. That's for certain. Alright, we've done that. Okay, so we've got a game studio up to date. We've got our dev time. I'm gonna say that that's, well, complete-ish. Got a feeling we might have to revisit that at some time to see if we can get it to work better. But I've got also a feeling that as our game studio grows, the effectiveness of that dev time will be okay. I don't feel as though it's going to cause us any problems now. Which I really didn't feel that way a week ago. Data and deserialize, we've got a basic system. File.io, we've got a system, a basic system. So we're really looking at probably starting up the Windows 32 API. You might have also noticed that I've changed it to dev underscore. The reason is that when you look at the files within a folder, it then groups them all together. That's the only reason. Rust project. As you can see, I've now got reference of Rustbook and Rust Sandbox. It just splits it all up nicely on here. I'm not really wanting to open it with that. Are we just allowed to open this in a terminal? We are. Okay. Can I type in cargo? New. No. I wonder if cargo will work from here. It does. Oh, Windows PowerShell. Well done, Windows. You're not letting me down so far. I'm impressed. I'm used to Linux, I'm sorry. When programming, I'm used to programming on Linux, and I can trust everything it does. On Windows, I'm never too sure what's going to happen next. So, whether we break links with libraries or God knows what, just by using a shell. Or which shell we use. Yeah, because there are multiple different standards of the shell. You've got administrative shells, you've got what is it, Visual Studio shells, you've got the standard command line shells. Yeah, what are you doing, Windows? Why not just have a prompt? A terminal prompt. They never did learn from Linux, did they? Oh well. Oh, by the way, if you do want to use Linux to program in, there's something called WSL2 available on Windows, which you can ask Windows 11 to use. And basically, you've got Linux. So if this system does mess me about, I do have Linux available to me. All I have to do is type in a couple of commands in here, and we have Linux. Yeah. So for all of those people out there saying, oh, you're not programming on Linux, it's optional. Don't have to. But now we get to one of the cruxes of what I want to do, and that is a development area for the Windows 32 API. And anybody that ever sees that shrinks away in horror. Done. Ba ba boom. There it is. What have I done? What have I done? Why have we got a target? I think we're going to be in the README for quite a while on this one. Make sure our setup is correct. Development of Win32 API, yeah, that's okay. Just run it. There you go, hello world. I don't like hello world. So I'm going to place in here a welcome message as always. Welcome to the Win32 API. There we go. That's better. And as far as a lot of people are concerned, you're welcome to it. And why is that? The Win32 API is, in the terms of C and C++ languages, the windows.h header file, which contains an awful lot of stuff to help you access some of the Windows 32 API. I believe there's also GDI.h as well for the GDI stuff, which we do have to go for as well. We will have to get that far somehow. So that's our welcome message. Put that in. I like having a welcome message, so we're going to have one. That's simple enough. Anything else we're going to need? No, not at this stage. Now, the Windows 32 API is based in C++ because Microsoft don't recognize or don't understand that there is something called a C language, or C. Is that a problem? Well, not really. We can get around that. Rust integrates with C. How's about those cookies? If we go through to the standard library documentation and we have a look under modules, we get something called FFI, utilities related to FFI bindings. This module provides utilities to handle data across non-Rust interfaces. Like other programming languages and the underlying operating system, Windows 32 API. It is mainly of use for foreign function interface, so FFI means foreign function interface, and code that needs to exchange C-like strings with other languages. Okay, so we seem to have a way in. What this means is we have operating strings, C strings, and stuff. So we've got on Unix and on Windows. So we do have an operating string, can be losslessly converted to a native Windows string. Why is this a thing? Well, we've been using strings in 32 and 64-bit. I think 64-bit actually at the moment. The Windows API doesn't. The Windows API began its life in 1993 and was designed for Windows 95. And to this day, all computers, when they boot, the first thing they do, or the only thing that they can do, at the very start of the boot sequence, the very first part of the boot sequence, is still, to this day, 16-bit. And the whole of the Windows 32 API, well, the strings are still 16-bit because of this. So one of the things that happens during the boot sequence is the initial part gets set up in 16-bit mode so that it can access the hard drive. It will then swap to 32-bit or 64-bit, depending on your system type, once it's got the initial file input output sorted out and everything loaded up that it needs to boot the system. That was a very simplistic overview. It's not quite that simplistic, but you get me drift. And that's the reason why Windows strings are still 16-bit. In fact, some things like, yeah, it says it here, an operating system string is a vector of U16. Unsigned integers, 16-bit, which are star chars, I believe, in C. Yeah. (16-bit) star chars. So we do have operating system string experimental and C string experimental, so we can't use these. These are experimental. There's a few more bits here. These are okay. So we can go into string from bytes and vectors. Alright. And we also have all of these aliases. Oh. The major one being this top one, C void. Rust does not have the idea of a void pointer. A pointer that points to nothingness, null. Nowhere. It's an error. A dangling pointer. That kind of thing. This is avoided in Rust. We have something called none, which is an error value instead. So we do need all of this lot. We do need, obviously, C void to be able to talk to C and C++. So this is damned useful. And there's also quite a few hidden things which I can't find in the manual on how to access the libraries. Yeah, because all of this Windows 32 API comes with it comes with Visual Studio. You can download it separately. That's the wrong one to do. If we look down at Visual Studio, the installer, okay, we press modify, and we have a look at C++ development, because they don't do C, of course. We see this at the top, if I can stop it from doing stupid things. I can't drag that. Great, thanks. MSVC version 143 VS Code 2022, C++, x64, x86 build tools latest. So that gives me build tools, but we also have this here, a Windows 11 SDK. Now if you haven't got this Windows 11 SDK on your system, you cannot access the Win32 API. Headers, libraries and tools for developing apps that run on Windows operating systems. And the big word there is libraries. We need to access those libraries. How do you get hold of them? Well, for me, I installed Visual Studio Community 2022, which downloads and installs this Windows 11 SDK. If you go to Microsoft and you look at Visual Studio Download, you'll also find in the very same area that you can download these separately. So you don't need the whole of Visual Studio. You can actually download the Windows 11 SDK and the MSVC build tool stuff separately. So if you're concerned and you don't want to use VS Community, then by all means, don't use it. Don't download it. Just download the other 2 bits. Otherwise, you're going to start coming across problems. So my build chain is using Microsoft. Yeah, I know. That's all interesting, but how does that help us? It means that we need something called bindings. We need to be able to access all of the stuff from Windows, the operating system, and that's in C++, theoretically. But we're going to access it as C, because that's the way we are. That's the way we like to rock and roll. We've just learnt something about mod.rs and how we can create a system. Okay, so if we go to our source folder, we can put a new folder in here. I'm going to call it the Win32 API. And this is why I wanted to know how to do the library bit, by the way. Because I knew that setting something up like the Windows 32 API could be a bit tricky. So I am going to add in mod.rs. Here. I'm also going to add into the source file window. Are we going to add a window here? I think we should, because this is going to be our interface. I'm tempted to call it an interface, but I don't think we need to. So I'm just going to call it window RS. This is where we're going to put our interface, how we create our window. That's going to be fun. And we need a goal. That's going to be fun as well. So what's our goal going to be? To create an interface with the OS Win32 API. Alright, that's simple enough, you might think. Yeah, of course it is. Create a window. And access the operating system events. Yeah, okay, we'll put that in there. Is there anything else we want to do at this stage? I think we only need the window and the events to get our game studio into a position where we can run a loop at this stage. So I'm going to leave it there. We do have to go onto graphics and keyboards. Mouse. So we do have mouse, keyboard, graphics, all the good stuff that the operating system, all those good things. So from here, we can see that we've got all of these aliases, type aliases. And we know we're going to need to access libraries. Let's make a note of that then. So types. Make a note of that by just doing that. Libraries, just call them, no, libraries. Operating system libraries, aren't they? I am going to call it OS libs, I think, for now. Those libraries are going to contain functions and structures which we need to access. So operating system functions, maybe. Let's do something like that then. These names may change. I'm just throwing ideas out there. Funks for a minute or two. These will probably get renamed. Anything else we can think of? Well, the libraries. Operating system events. Maybe. Alright. Operating system events. I'm going to pop that one in just in case. Alright. You can see already what's happening. The Windows 32 API is going to take some work. Which is fine. I don't mind that. None of this is tied together at the moment, don't worry. Am I okay with all of this? Yeah, I think I am. I think we'll get rid of all this garbage. Alright. Right. So it's the Windows 32 API. I'm just going to steal this one. I think that was right. Okay. Right, we're going to need some references. Let's see what we can find. Let's try MS Win 32 API. Let's try that. Ah, Microsoft Learn. Here we go. Programming reference for the Win32 API. Is this any use? Yes, it is. We've got Windows code samples. We've got all of this stuff in the Windows 32 API. It's pretty large. Remember that I said it started in 1993? Yeah. This stuff's over 30 years old. Oh, we also have Direct 3D and Direct 2D. Windows GDI is the thing that we're probably using for input and output. I haven't looked at it yet. So yeah, I think this is our main location. Okay. So this is the reference for the Win32 API. How do they do it? To API main menu. Yeah, we'll call it that, main menu, I think. And we'll just grab you and we'll pop you in. Lovely. How long would it take to read through everything? Quite a bit. I think we're interested in this. I'm not overly bothered about the code samples, I don't think. Alright. I don't think sample gallery. Blah 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 blah. It's pointing me to Microsoft Store. Source code. Samples native. Alright, so we've got some stuff in here. Let's have a quick look at the gallery. And notice it using XAMLs here. That's C# area. Different SDKs, animation, input. Oh. Gestures, input cursor, and it's a XAML. Don't think this is too useful. That's Windows RT, isn't it? Not 32. There's two different APIs going on at the same time. WinRT and Win32. We're interested in Win32. WinRT. Yeah. Demos. A material creator. Yeah, C#. Okay. Oh well. We looked. I'm not overly interested in C#. Toolkits and helpers. Again, pointing us to the store. WinUI. Do 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 do. C++ language documentation. Ooh. Nice. Yeah. There's all of that garbage. Windows and messages. The functions that we can access. Nice. So there's close window, create a window A, create window EXA, create window EXW, create window W. Yeah. So that's 1, 2, 3, 4 different versions of create window. Lovely. Which one will we be using? Well, we'll be using, well, that's ANSI. A stands for ANSI. Extended means, does it have menus and stuff? Does it have controls on the window? W means word. Words would be used for Unicode, not ANSI, which is UTF-8. So this is 8-bit, this is 16-bit. Word of warning. If you use UTF-8 as your standard for your program, you cannot convert it to other languages that have large character sets in it. Like Japanese. You're limiting what you can do. You can probably get away with English, some European languages. Unicode also gives you emojis. I think we should, because of our operating system being 64-bit, I think we should go with the largest. So we're going to be using a W, one of these two. Creates an overlapped pop-up or child window with an extended window style. Otherwise, this function is identical to the create window function in Unicode. Creates an overlapped pop-up or child window. So extended window style you get. Window styling. I think we're going to be going with this EXW. Okay. This is a learning center, isn't it? Windows and messages. Do you have a learning center in here? WinDef. So these are the header files. Oh my god. I didn't want to do that. Is it? Okay. So WinUser seems to be the main one. That's got the WinMain function. These are all contained within Windows.h. I have no idea what an olectal.h is. the Windows base, the Windows definition, the Windows extension possibly, and obviously the user. What's this? Is used by multiple technologies. The component object model. Yeah, we've got comms to deal with, haven't we? Servers. What does OLE stand for? Picture object created from stream. Converts an icon to a cursor. I don't know what OLE stands for. And then we've got OLE, and that's icon. Right, okay. OLE. Involving documents. In this module you'll learn how to, you won't learn much unless you read everything, to work with document data and about document standards in Business Central. Okay. So how do I learn more about this? It doesn't seem to be obvious. Go back to our Windows control here. Design, develop. Alright. Is there anything else I've clicked on in here? Not really. Build desktop Windows apps using the Windows 32. Get started, design, develop. Alright. Graphics and gaming. DirectX. Oh, it's got a lot in here. That's good. Oh, wait a minute. There's things I've clicked on in here, isn't there? Ah, tutorial. So they actually have a tutorial in here. Look at this, create a window. We've got a tutorial, peeps. Yeah. And it's in C++. Proceed to window messages. Okay. We've got a full tutorial here. So this is a Windows, this is the Microsoft tutorial for Windows 32 and C++. Alright. So this is going to be the Win32 API MS tutorials. Get started. I don't like that. Alright, well I think we'll go with that then. we've actually got Windows graphics user inputs in here. Using your comms, remember, in your Windows program. Component object models, that's in here. Okay, looks straightforward. MS2, yeah, okay. We'll take it. We'll take it. Alright, we've got that. Okay, C++ language documentation. Alright, let's just have a quick look at that as well. Oh. What the hell? What's this got to do with it? This is a download page. WTF? Okay, Windows. Variable. We know we're going to need types. So Windows data types. Base tsd.h. Windows coding conventions. Yeah, type defs. Alright, well this is actually telling us what they are. Nearly. Alright. Have we got anything better than this? If you don't know how to read these, they're quite simple. Let's just have a look at a couple. So you've got a D word means something. D. Why D? Int 32s, int 64s, we understand that. Longs are 32-bit. I think this is a floating point, maybe. Long is 64 bits, yeah. Uints, that's unsigned long, long. So these are just types of variables and a word. Alright, I'm not sure what that D is for. Okay. Boolean types, false is 0, as we know, true is 1. Yeah, we already know that. We've actually got that in the language, so we don't care about that one. Underscore pointer, but that's not normally how they do it. They normally just put a P here, like DP word or pint, P-long. Yeah. So this isn't really that good. Programming reference. Data type cheat sheet. VBA. It's PDF. Declarations. Bool, yeah. Boolean. Oh, I like this. We're going to have to convert all of these over to Rust. What does it say for a handle? A handle to an object, and it just says it's a long pointer. That's not very useful to us. Okay. Okay, interface elements, Got all of this that we can have a go at. My god, there's tons. User input's going to be funny as hell. Types. Where's types? I don't want that then. It's coming up with this quite a lot, so let's have a quick look at this. Yeah, here we go. So what do these guys call a handle? P void handle. So that's a pointer that's void. Yep, this is useful. So this tells us all of the types that it's going to be using, or well, some of them anyway. What is a D word? Just out of interest. Where is a D word? There's handles. There it is. A 32-bit unsigned integer. This type is declared in whatever as follows. Just an unsigned int. Alright. One, two, three. 1, 2, 3. 1, 2, 3. 4 seconds. Just thinking about that U128 from earlier. I see. And that's why it's a U128. Interesting. Sorry. Got distracted. Right, this is a list of all the types. We're going to need that. So Windows data types. Interesting. So this is Win32 data types, they call it. Fine. We're going to take that. Alrighty. So we've got data types now. What else can we have? Functions. I think the functions are just under the C++ reference. Will we need them at this stage? Probably. No. Alright. Windows code samples, Windows and messages, user interface and desktop, yeah. Functions. Ah, we've got all the functions here. Yeah, we have. Just have a quick look at this, see what the syntax is like. Parameters, remarks, okay. Do you tell me where it is? See extended window. Oh yeah, I like this already. Tells me what each of the items is. So as you can see, handle to the window, hwind. H menu, handle for the menu. Handle for the instance. A long pointer to avoid null pointer. You can just read them. It's quite straightforward. Remarks. Destroying the window edit, yeah. Static, yeah. Yeah, example. Nice. Requirements, here we go. library, user32.lib. We need to know the library for each function. And then we need to access each function within that library. They're saying user32.lib, DLL user32.dll is on the system in the system path, so we don't need the DLLs. Nice. How do we put that into Rust? How on earth are we going to get hold of, say, the user32 library? It's going to be a C external. Alright. So this is a standard library. Do we have an extern in the standard library? We've got extend, keyword extern. Link to or import external code. So we can hash link. The mirror use is no mangle if we're going back to C, but coming from C, we just do a link to a C library. Isn't this unsafe? It probably will be. For more information on FFI, check the Rust book or the reference. Okay. So we're going to need to use something like this in our libs RS, operating system libs. Types we can do, FFI we can do, extern sources we can do. What are we missing? Function definitions. That'll just be extern C. And we can make them public or not. Right, I've done some research into this, looked across the web, and I'm not going to use it for this project, but something you might be interested in. Triangle from scratch tutorial. So OpenGL from scratch, and it does go through some of the things that we might need in here. Don't really like this one. Nah, I don't like that one. That's the GitHub pages. Ba 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 ba. Oh, it's really homed in on this, hasn't it? That's unusual. Tutorials, yeah, Reddit, tutorials, JetBrains. Okay. No, I don't like any of this. That's not really come up with what I asked for. Opening a window. Clean up. Yeah, So there's tons of like this kind of stuff. These numbers. We're going to need all of these numbers, like this enum thing here. So we're going to have a lot of research to do to get hold of the conversions into Windows. Don't know how much we can get from Microsoft. Yeah, okay. That looks interesting. Alright. So, yeah. We've got a window class. They're using W instead of EXW. Alright. So it's hash represent C. And then you put in the structure. And of course they've got the types underneath, yeah. That's fine. So this is how we're going to be doing that. So I've done quite a bit of research into this already. So what I've done, is under Rust project, I've now got a reference area, and you might notice that I've got a Windows 32 reference here, API, where I've tried to look at these kind of things. So I can open that. So yeah, it is. It's this represent, like, would have a... I've used window class W here as well. Maybe we'll just use that then, not the extended version. But I've also added an unsafe implementation default zeroed, which means it zeroes this thing out. So we have a default implementation. So that will be like the window class W. Interesting. I mean, how is this... Why is this different? That's interesting. So this is the window. This is the kind of code they're going to give us. In this section, creating a window. Alright. So, win class. What are they using? Does it matter? Yes, it matters. Yeah, they're using window EX. We're going to have to make a decision about this Windows stuff, aren't we? Might just go with window class W. I know window class W works perfectly well. It's only using uints, winprocs, hints, hi. Handle to an icon, handle to a cursor, handle to a brush which is for painting the window. A long pointer to a string, CW. What the C stands for. W is a window. Component? Possibly. Don't know. Win class W. Yeah. What else are we using in here? Messages. Paint struct. A rectangle. Sounds good. There's not too much rubbish in here. I did look up how to make a macro for the unsafe implementation default zeroed, just to make sure that the core memory was zeroed out, which we're allowed to do. So it's inline, must use. Yeah, that's fine. I think we're alright. Windows 32 types, yeah. So we did need the types for this. Yeah, this is looking okay. This kind of structure is looking okay. Oh yes, the strings. So turns a Rust string slice into a null terminated UTF-16 vector. Oh, door, just one sec. Oh dear. Alright, well once we've seem to be on a break, we'll just grab a drink. So, yeah, I have been skimming over this a little bit, haven't I? There's quite a lot to the Windows 32 API. I think we can start from here and work our way into it. Yeah, I think we'll be alright with that. Just graphics, audio. Yeah. That's just your overview. Do you actually give the code for that part? No. Do you give it in here? Yeah, you do. And that takes us... Jesus. I think we've got a start point. It's gonna be tricky because the documentation, I think some of these links are broken. But we can go directly to the function. user.h, I see. It's looking as though we are going to need a list of the C++ stuff. So I'm going to take this functions thing by the looks of it. Win32 functions. Yeah, I'm going to take this as a link. Might not be the right link, but at least we've got something to be able to look up. So we've got tutorial types functions. The functions gives us the libs. Events. Oh god, I haven't even gone there. I think we'll leave that until later. We've got enough to be going on with. Yeah, there's a lot of reference material within the Win32 Microsoft area. Functions and structures. All right, that's going to be helpful. It's big, very big, a lot bigger than people think. I'm only looking at a small little bit of it called create a window. Size, style, the Windows procedure. Ah, we've got the extras here. Probably don't need that. Yeah, I think we're going to go with class W. It still has the extras in. Icon cursor, background menu, class. Okay, and some strange notations here which need to be explained. Okay. Icon cursor, background, menu name. We don't really need a menu for a game thing. Class name. So is it just the menu? Is that the only difference? What about the icon? I think we're okay with that. There's two icons. One is for the top left hand corner, the icon that goes in the top left hand corner. The other one is for the icon that goes down here. That'll be the second one here. So there's two of those. Yeah, okay. Yeah, there's only one icon. There is a menu name. We'll zero it out. We'll get rid of that. Lovely. A little bit of trial by fire. Obviously I've tried this out, tested it out, see whether it works or not within Rust, and it does work within Rust. It's just not easy to do. What I haven't decided upon is this structure stuff, how we're going to structure it all out, because the Windows 32 API does not just open a window. It deals with all functionalities of the operating system. Everything from file I/O, keyboard, mouse, any peripherals you've got, the graphics card, which we'll need access to be able to actually draw to the window. So if we can get a decent way of doing things, all of a sudden it's going to open up the whole API. So after we've done the first lot, a lot of this will be reusable or extendable, one of the two. But there isn't just the Windows 32 API, there is the DirectX API. I'm not sure, are we going to use DirectX? Are we going to use OpenGL? Maybe you want to go with Vulkan. I haven't downloaded the Vulkan SDK onto this machine, if we wanted to go that way. OpenGL and DirectX should be accessible without any downloads. They're all valid. I think we should be alright with this. There is something that's hiding away within the Rust code. Will I be able to show it from here? Let's try HAND. Yeah, it's there. There's another area available on Windows only. This is in STD OS Windows Raw. It's not in FFI at all. But you can see that it's using FFI. But that isn't. That's a standard OS Raw C void. That's a duplication of code, isn't it? So there is a module within Rust for Windows. So we've got FSIO, Prelude, Process, Raw and Thread. So operating system Windows Prelude. Which gives us metadata, handles, sockets, basically handles. So we already have that handle defined. Even if you look at this, you can't see the handle. So this is hidden. Why? Windows Raw, which has got handles and sockets in it for dealing with internet communications on the sockets, definitely, through the Windows API. I find that a little interesting, the way this has just been hidden away. I didn't even know it existed until last week. Yeah. So FFI is not the only answer. There is an operating system Windows. So we've got Darwin, Linux, Raw, Unix, WASI, WebAssembly, WASIP, WebAssembly Systems Interface, Windows, platform specific to the standards of Windows. Yeah. So if you didn't know this existed, it does. And again, compatibility module for C platform specific types, use core FFI instead. So I think we'll be using core FFI. Because it does say to use it. Alright. What we need to do is work out next what we're going to put in here. This is going to be our Windows interface for Windows, the creation and destruction of Windows. I'm not sure about the event handling. I usually create a separate event handler. What are the kind of things we will want for this? That's a good question, isn't it, really? Yeah, go on, I'll just open you up in here. Okay. We'll just get rid of that lot. I think I got them on the wrong way round. Yeah, that's better. All right. What kind of things are we looking at? It's going to be interesting because we're going to need a window structure of some kind. I think we can tell that because we've got this under app here. We've got this line that's saying, hey, let's store a window. I don't think we're going to need an FBox render window thingy, but render window does sound interesting. So this is going to be an interface for creating a window using the Win32 API. Probably need structure. I'm not going to call it a render window. Window structure. For access to Win32 function calls, I suppose. I'm not sure. For access to Win32 functionality. Like I say, I tend to this will be the interface implementation. So what we're going to have in here? Why is that an error? Oh right, we haven't included you, of course. Where is it? It's next door to us. We'll just throw it in as a module for now. Okay. Syntax is not a valid Rust item. It's got nothing to do with it being a valid Rust item. It's because it's not in anything that inside anything that's valid. Okay. Can't do that. Alright. Right, so we're going to need create window. So create window, probably. Don't know what we're going to have in there. Anything else we're going to need here? Not really. Will we need it anywhere else in here? Probably not. Input events is separated off. I'm trying to think of the architecture for this. We could put a poll events in here to start off with. How are we going to close? We are going to have a closing event of some kind. But not straight away. I don't like the idea of putting polling in here, you see. Maybe we don't. Maybe we do not. Maybe we have to put an events in here. I usually call it input, don't I? Alright. This is gonna be go awkward, isn't it? But it is looking as though we're going to go down that road. Cross the bridge when we get to it? Probably. That's all we need. Initially. How are we going to keep it open? We may need to throw a while loop up. And then we will need to poll events. Alright. That's where we want to start though. Okay. So we've got a welcome message. We're looking to create a window. Run a main loop. This is going to be bad because we've got no timer on this. Don't really like the idea of running a main loop. Maybe we will. Okay. We will need to poll to start off with at least operating system events. that should do. And I think I'm going to put a shutdown here because I don't know if we need one or not. That's the simplest I can come up with. Yeah, I'm not certain about it. So create a window, run a small loop, poly OS events, and shut down. Are we allowed to do that? Can we have an automatic system poll events? Possibly. I think I've got a base set up that isn't going to complicate things too much. We're looking at something very, very simple and straightforward here. And then we're going to be looking mainly at a lot of things in the operating system areas to make this happen. My God, this is going to be fun. Yeah, I think I'm okay with this. How are we going to do it here? We're just going to do a create window, so we need to write this first. Okay, I think that's all right. We've got 11. We haven't linked everything together. All right. And I don't know how those are going to link. Huh. We're going to have a module. What? For all right, OS events, and it's not coming up because we haven't included this in anything. It's not really going to give us any kind of feedback on this. Alright, we'll just have to do it without until we can tie it together. Funcs, yeah. This is what I mean, we're not going to get any errors or anything. Operating system libs. And types. How does all of this fit together? I'm not quite sure. We may have to do the self thing. I've never used this mod.rs thing before. I've always just gone through another file to get there. So this is more experimental for me again. Not sure if I'm going to need anything else in there. At this stage, anyway. Maybe this one we will. We're going to have a window class. Hold on a minute. So in here... Oh no, we can have a Win32 class, can't we? Yeah. Okay. Naming conventions are going to be a bit awkward because there's so many different files. But I think I can get around that. What I'm more worried about is how do I get these like type RS. We have to tie it into here first. Gotcha. Alright, this makes sense, but not too much sense. I'm not sure how it all ties together. That's going to be part of the journey. So, it looks as though we're going to be setting off on a journey into the Windows 32 API. Currently, let's save that out. I'm just going to leave it as is. Yeah. So this, I'm going to take this as a base setup for now. I'm not overly confident in it, to be honest. I mean, if anybody's got any ideas on how we should approach this, feel free. You know, in the comments and stuff. But at the same time, is there a good way to approach the Windows 32 API? There you go. Did we finish and add the Delta time clock? Yes, we did. Thank you. That's a good start. So we've actually got a Delta time clock now in our Game Dev Studio. We've done it in a way that is causing me problems developing, but we'll see. We'll see if I get used to it. Hopefully I will. And we'll sort things out as we go. It's going to be interesting. I've got loads of reference material now on Windows 32. So I'm hoping we're going to be able to just cruise through the code side of it. No idea how we set it all up so that it works efficiently and in a way that's useful to us in the future. That part of it's going to be very interesting, especially for me, putting the jigsaw pieces together. That's the way I look at it. In the meantime, I'd like you all to take care and have fun.